This video is going to be on writing the proofs using CPCTC. We need to prove that triangles are congruent using a regular proof, and then we're going to prove that the additional information is congruent. So on this problem, we're given that segment AC is congruent to segment AR, and then angle 1 is congruent to angle 2. But we want to prove in the end that angle 3 is congruent to angle 4. Since this does not say prove triangles congruent, it says to prove an angle is congruent to an angle, we must prove that triangles are congruent first, because this is going to be a corresponding part. So once you have that the triangles are congruent, you can prove that any corresponding part is also congruent. So we must always prove that the triangles themselves are congruent first. So if we start with our given, as always, our first statement will be that segment AC is congruent to segment AR because it's given to us. Now I'm going to go into the picture and mark that. So segment AC is congruent to segment AR. This is congruent, so I can put a check mark saying that yes, that has been marked congruent, it's in our proof, and it's on our picture. Our second statement also comes from our given. Angle 1 is congruent to angle 2 because it's given to us. So I need to go over to the picture. Here's angle 1, it's an angle, so I use an arc. And angle 2, I use an arc. It's in my proof, it is marked congruent, I can put a check mark. This is all that I have in my given. That means that I only have two things marked congruent. I need to find a third thing so that I can prove the triangles are congruent. So using the triangle, I can see that the triangles are touching each other. I do not want to focus on 3 and 4 because I cannot prove those until I've proven the triangles are congruent. So I need to figure out a third thing to prove that the triangles are congruent. This will be my last part, so I can't use it right now at all. This will literally be the last part of my statement. So since the triangles are touching here and it forms an X, that means we're actually going to have vertical angles. So I know that for reason 3, I'm going to have vertical angles. Vertical angles are congruent, so I just need to make sure I name these correctly. I know I want to have these two arcs, these two angles. So I'm going to name it from this triangle first, and it does not matter how you name it as long as your arc, your A, is in the middle. So if I name this angle CAL, is congruent to angle. So again, it does not matter if I named it CAL or LAC, as long as A is in the middle. I cannot just say A is congruent to A because there's too many things at A. I have to be very specific in saying that this is the angle I want. So since I use CAL, I have to start with what corresponds to C. C has no arcs on it. So on this triangle, the R has no arcs on it. So I would have to start with angle R. Then I wanted to go to A, which has the two pink arcs. So I'm going to go to the A, which also has two pink arcs. So RA. And then the last angle is S. The last letter was S. So angle CAL is congruent to angle RAS by vertical angles. Now I have 1, 2, 3 parts already marked congruent. So I can now prove triangles congruent by side, 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 angle, 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 side, or HL. I have a side, so I'm going to put an S here. This is an angle. This is an angle. Again, this does not tell us the order of it, but it does tell us which ones to look at. So I have two angles and a side, so I know I have to look at these two to determine it. I know it won't be one of these because I don't have those markings. So it's either angle, side, angle, or angle, angle, side. So coming back to this picture, I have my two angles. Now is this side touching only one of the marked angles or both of them? Now again, it's going to the marked angles, my arcs. This side, if I were to outline it, is only touching this marked angle, this pink. So it's only touching one of the marked angles. So up here, this one touches both of the marked angles, so that's not good. This one touches only one of the A's. So this is what I want, angle, angle, side. So we can prove that these two triangles are congruent since we have two angles and this side is only touching one of the marked angles. We can prove it by angle, angle, side. So we know that it's going to be congruent by angle, angle, side. Now I have to write my statement. What is congruent? I know we're dealing with triangles. Since it doesn't tell me the order of the triangles, because my proof says I want to prove something extra, I can actually name the triangles the same way I named my vertical angles. As long as they're correct, I can name them the same way. So triangle CAL is congruent to triangle RAS by angle, angle, side. Now, we've proven that the triangle is congruent, so we can now say that corresponding parts of the congruent triangles are congruent. We've done this part already. We finished this part. Now we just say that the corresponding parts are congruent. So any of the three remaining corresponding parts will be congruent. Well, angle 3 and angle 4, those are actually corresponding parts of the two triangles. Because angle 3 is in this first triangle, is at C, and angle 4 is in this triangle up at R. So now these are one of the three parts that are still left of the triangles that have not been marked. That means that we can actually prove them congruent because the triangles are congruent. We have the first three parts already congruent. We can prove the next three parts. But I don't have to prove all three of them like I did up here. I just need to prove one additional part, the one that it wants me to. So if angle 3 and angle 4 are corresponding to each other in regards to the triangles, then that means that I can actually say that yes, they are congruent. So we can say that angle 3 is congruent to angle 4 because of CPCTC. Because we've proven that the triangles are congruent. This has already been proven. So then these are corresponding parts and they have to be congruent. So if I'm going to do 3 more proofs using CPCTC. So again, we always start with our given. So in our first given, we have angle NLM is congruent to angle LNO because it's given. I want to mark it. So NLM, so I know it's in this triangle. This angle is congruent to angle LNO. L to N, O. So I know it's over in here because this is my vertex. It's in my picture. It's in my proof. It's congruent. Check mark. Then the next one is angle OLN is congruent to angle MNL because of given. So we go OLN. So L is at our vertex. I'm going to have 2 arcs here. MNL. So MNL. This is my vertex. It's in the middle. So I have 2 arcs here. It's in our proof. It's marked in our picture. It's congruent. Check mark. Those are all of our givens. We have 2 check marks. We need a third one. Or we need a third piece. Again, we always prove triangles congruent. We have to prove the triangles congruent first. So that's all of our givens. So we have to look at our picture. Our picture, the 2 triangles are touching at a side. Since they share that entire side, we should know that that's going to be reflexive property. So I'm going to go ahead and put reflexive property, prop. Now all it takes is to name this. Now, if you remember with reflexive property, you have to be sure that the letters correspond to the correct letters. So if we focus on one set of letters, so we focus on this triangle right here. If I make a little congruency mark here, I see if I go from L to N, I can say from L to N. So I'm going to say segment LN is congruent. So again, I'm going to look back at that. L to N. I go from 1 arc to 2 arcs. So I got to remember that. 1 to 2. 1 to 2. So I have to cover up this other triangle. Start on this side. Again, it went from 1 to 2. So on this one, from 1 to 2 goes the opposite direction. So from one arc actually has the N there. So it's actually congruent to N, then L. So congruent to segment NL. It's because of the way that the shape is, because of the arcs, they're in a different location. That means that the side here is going to be named differently with regards to the two different triangles. So now that we have 1, 2, 3 things marked congruent, I can go back through and just say, okay, this is an angle, this is an angle, this is a side. So I have 2 angles in the side, and again, it does not tell us the order, but it does tell us that we have 2 angles in the side. So look at your side. Does it touch one of the marked angles or both of the marked angles? So if I cover this one up, if I were to outline this side, it will actually touch both of the marked angles. So that means that the side is in the middle, so it would be angle, side, angle. Angle, side, angle. What about on this one? On this triangle, this side would also touch both of the marked angles if I were to outline it. So this would also be angle, side, angle. Since these are both the same, we can say that the triangles are congruent by angle, side, angle. So again, angle, side, angle is our reason now to write our actual statement. Now, since it, again, does not tell us the actual order of the letters for our triangles, we can name our triangles the same way we named one of our angles. That doesn't matter. So we can say triangle, if I just go back up to this first angle, triangle NLM is congruent to triangle LNO by angle, side, angle. So once the triangles are congruent, we can name any additional part, as long as it's an angle or a side. So angle M and angle O was what we want to prove. Angle M and angle O are not marked already. These are corresponding parts of the two triangles. And now these two triangles are congruent because we just proved that. So now the corresponding parts are congruent, the extra 3 parts, but we only want to focus on one of them. So this extra part, angle M, is congruent to angle O because those are corresponding parts of these congruent triangles. So corresponding parts of these congruent triangles are in fact congruent to each other. On this next proof, again, we start with our givens. So it says that segment AC is congruent to segment BC because of given. So I'm going to mark that. Segment AC has a mark on it. It's congruent to segment BC has a tick mark on it as well. It's in our proof. It's marked. It says it's congruent. Check. Second statement is AX, segment AX is congruent to segment BX because it is given. So A to X is congruent to B to X. It's also a segment. So I'm going to put 2 tick marks on it. So it's in our proof. It's in our picture. It says it's marked congruent. Check. These are all of our givens. Since we only have 2 parts, that means that we have to go back to our picture to find a third thing that's congruent. So these 2 triangles are actually touching at an entire side. That means that we will have reflexive property. So we'll have reflexive prop. That means we can mark this side congruent to each other. Now we just got to name it. So if we have to be very careful on this because we have to know on this one we had to flip the letters because of the way the arcs went. We had to go from 1 arc to 2 arcs, then 1 arc to 2 arcs. On here, we have no arcs to really help us. So if we look through this, if we start with segment CX, let's just start with CX for this first triangle. Because again, that first way you name it doesn't matter as long as you name it with what you want. So we went from C to X. Because there are no arcs, I have to look to see where the letters are in regards to the tick marks. That's a little different. So I started with C. If I wanted to outline C, I would go through the 1 tick mark to the 3 tick marks. So I have to go from 1 tick mark to 3 tick marks. That's how I got the C. Now, if I do that same thing on this other triangle, I want to go from 1 tick mark and outline the angle that goes to the 3 tick marks. So if I start with 1, I see 3 is over here. I don't go all the way around. I go from 1 tick mark up, so then I can go to 3 tick marks. So that angle up there is also C. So segment CX is actually congruent to segment CX. So again, that's the difference between these. Still the same reason, but the letters that you use are backwards in this one, but they're the exact same order in this one because of the way the shape is made. That's why you have to be very careful when you do the reflexive property to name them correctly. Now that we have 1, 2, 3 things congruent, we can see if the triangles are congruent. We have a side, we have a side, we have a side. So we actually have SSS, and the only way we can that works is if we have side, side, side. So that means that our triangles are in fact congruent by side, side, side. So we can say over here, side, side, side. Now just to name them. Again, since there are no arcs here, we just have to name the first triangle one way, and then the second triangle, we name it with corresponding to the first one. So the triangle, if we say ACX, because this is the first triangle, triangle ACX is congruent to triangle. So A goes between 1 tick mark to 2 tick marks. So let's do the same thing over here. So here's our 1 tick mark. There's our 2. So we go from 1 to 2. So we have to start with B. So B, if we go to C, we go from 1 to 3. So do the same thing. 1 to 3. So that's also at C. And then the last letter is X. You just have to figure out where the first 2 letters are, because then the third letter has to be that third letter. So the triangles are congruent. Now that the triangles are congruent, we have the 3 sides are congruent. So that means that we can prove all 3 of the angles congruent, but we actually only want to focus on one of them, one set. We have to make sure these are corresponding. Do angle 1 and angle 2 correspond to each other? Are they in that same location? Angle 1 is between the 1 and the 3, and so is angle 2 between the 1 and the 3 markings. So these do in fact correspond to each other. So then these are congruent because of CPCTC. So angle 1 is in fact congruent to angle 2 because of CPCTC. You prove the triangle's congruent by side, 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 so then the corresponding parts have to be congruent. This last proof, again, we're going to start with our givens. So angle 1 is congruent to angle 2 because it's given. I want to go to the picture. Angle 1, angle has an arc, so 1 arc here, and angle 2 is going to have 1 arc on it. It's in our proof, it's in our picture, it says congruent, check. Next part, angle 3 is congruent to angle 4. It's in our given, so that's the reason why. Okay, so angle 3 is an angle, so I should have 2 arcs on it. Angle 4 should also have 2 arcs on it. It's in our proof, it's in our picture, it says congruent, check. Now we have 2 things marked congruent, we need that third. So that means we go back to our picture. And if you look at our picture, these 2 triangles are touching at an entire side. That tells us that should be the reflexive property. So we can mark this side congruent. Now we just got to name it. So again, always with reflexive property, you have to use the angles or the sides or anything else to help you know which order to go. So that first triangle, it's going to name it ZX because it goes from 1 to 2 arcs. So I'm just going to name it Z to X, 1 to 2 arcs. So segment ZX is congruent to segment. Okay. So again, I went from 1 to 2. So if I go to the other triangle, here's the 1 arc, which is actually at letter X. So it goes, instead of from Z to X, it goes from X up to Z. So it's congruent to segment XZ. Because of the reflexive property of congruence. We have 1, 2, 3 things. So this first thing is an angle. The second thing is an angle. This third thing is a side. Again, this just tells us that we have two angles and a side, but we don't know the order of it. It just lets us know that we're looking at two angles and a side. So does this side actually touch one of the marked angles or both of the marked angles? So if I were to look at just one triangle at a time, this side right here, if I were to outline it, touches both of the arcs. So the one arc here and the two arcs touches both of them. That means that that angle has to be, that side has to be between the two angles. So it's not angle, angle, side. It should be angle, side, angle, because that side has to touch both of the angles. If I do the same thing for the second triangle, if I outline this side, it will touch both of the marked angles. So that side is in between them, so it would be angle, side, angle. We still have two angles in one side, just like it says we should have, but now we can look to see that the side is in between it. So it is in fact congruent by angle, side, angle. Now we just need to say the statement. So nowhere up here does it say the angles in any order, so we just name one of the triangles any way we want to. Triangle, so if we just name it triangle WZX, is congruent to triangle. Okay, so W, we have to start with W, that has no arcs on it. So over on here we have Y has no arcs on it. So we start with Y. The Z. The Z, if we looked at this triangle, had the one arc on it. So coming over here, the X has the one arc on it this time. So we would say YX. And then the last letter is Z, by angle, side, angle. Now that we've proven the triangle is congruent, we had everything to prove the triangle is congruent, we can prove the other three parts. So we had two angles in the side. That means we could prove the third angle and the other two sides congruent because of CPCTC. So it's asking us to prove the segment XY is congruent to segment ZW. Now if we check that, they have to be corresponding. X to Y. So it goes from one arc to no arcs. And then it says ZW. So one arc to no arcs. Those do in fact correspond. So since the triangles are congruent, these are corresponding parts. So our corresponding parts of our congruent triangles have to be congruent. That means that we can say that segment XY is congruent to segment ZW. Because the corresponding parts, these are corresponding, of these congruent triangles, since we've already done that, these have to be congruent.